Yeah, hello everyone. So, welcome to CH.MARUTHI tutorials. Today's the topic is Mendeleev's periodic table. Okay. Earlier to this, we have already discussed regarding Robert Boyle's classification of elements. Later on, Jobinius. Later on, Newland's concept of octaves. Right. Now, when we got to a thing that chemical properties are very important, the first person to come forward is nothing but Newland's concept. Then to that one, basing upon chemical properties, the very important one, it's nothing but atomic weight or atomic masses. Now, let's discuss regarding the Mendeleev's periodic table. Right. So, our side chemist, Mendeleev's, definitely he has put forward a beautiful one. Of course, it has certain limitations, but frankly speaking, it is one of the best. Of course, it laid foundation for the next one, that is the modern periodic table, which we are using now. If you come forward, if you get into the picture now, Mendeleev's periodic table. Mendeleev's periodic table is based on both physical and chemical properties, but the main property what he is dealing is nothing but atomic mass or atomic weight. That's what he says. Mendeleev's periodic table is based on physical and chemical properties of elements of their atomic masses or atomic weights. That's the main thing. He is dependent on, right, the chemical property, which is very important. That is nothing but atomic mass or atomic weight. You have to consider that one. Now, the total table what he has classified, so he was focusing mainly into groups and columns. Right. So for the entire design, he was talking about a law, Mendeleev's periodical law. So what does Mendeleev's periodical law says? Here comes. Physical and chemical properties of the elements are the periodic function of their atomic weights. Right. I repeat, physical and chemical properties of the elements are the periodic functions of their atomic weights. This is the law on which the entire periodic table has been classified. So, if you come across Mendeleev's periodic table, right, the total table what we are able to see here, he is basing upon the law, Mendeleev's periodic law. So, which he says, all the properties of the elements are totally dependent on the periodicity of the elements, and that too atomic weight. So, now, what is this periodicity? Right, you have to consider this one. Right. So, generally, if the properties of the elements are repeating at particular interval of time, right, like this, as if in the Newlands, the properties has been repeating for every eighth element. It's a sort of repetition of the eighth. Means, if the first one, again, it is repetition of the eighth. Second one, if the elements are arranged in a particular order, any order, or of course he has taken in the increasing order of their atomic weights, after arranging, if the properties have been repeating at a particular interval, then we call it as periodicity of the elements. That's what he says. The repetition of the properties of the elements after certain interval, any interval. Right, Newlands has taken an interval of 8, and here also he is having certain interval. Right, means I am talking about periodicity. Right, repetition of the properties of the elements at particular intervals is called periodicity. That's what the law. Let's go back to the law. Physical and chemical properties of the elements are the periodic function of their atomic weight. Now. If you think about the table what is given here, right, he has divided the entire table in terms of groups and periods. Let us see here. Right. So, the vertical one are nothing but the groups according to Mr. Mendeleev. The vertical columns in this table is nothing but the groups. And the horizontal rows, right, the horizontal one, these are nothing but the, right, it's nothing but, what's that? Periods. We have to consider that one. That's what he says, right. Features of the Mendeleev periodic table. Elements are arranged in the increasing order of their atomic weight. So, all the elements what are all present there, available at the time, he has arranged in the increasing order of their atomic weight. First he took the smallest, then he increased, then he increased, then he increased. Means all the available elements he has arranged in the increasing order, step by step. He has arranged in the increasing order of the atomic weights. That is the first one. The next one. Elements are arranged in the increasing order of atomic weight. Now, the table is divided. Now you can see the table here. The entire table he has divided into groups and periods. So, which are called groups? Just now I said, right. The vertical columns, that's what he says. Table is divided into 8 vertical columns called as groups. The vertical columns here he is calling it as groups. And how many vertical columns are there? How many groups are there? Totally 8 he is talking about. The next one, 7 horizontal rows called as periods, right? So, he is considering 1, 2, totally, if you count that one, he has classified into 7 periods, okay? Now, what about the properties, right? How the properties are in the groups and how the properties are in the periods. So, let's consider that one. If you see here, each group is again, here the very important one. Every group, right, totally we have considered, right, the vertical one has groups. Again, every group he has divided into 2 subgroups. If you check it out, right, in the first group itself, few elements are towards this side and few elements are towards that side. So here few elements are there and towards the other side we are having few elements, right? Each group, again he has divided into subgroups. This is a very important point. So the thing which we didn't see in the new lands or whoever, right? He has divided every group into 2 subgroups. Subgroup A and subgroup B are 1A and 1B. 2A and 2B. Means in the first group he has divided into 2 subgroups. 1A, 1B. In the second group, again 2 subgroups are there. 2A and 2B. That is the point to be noted. Each group is again divided into A and B subgroups. We are not talking about periods. We are talking about only groups. Each group again divided into 2 subgroups. Now, let us think about how the properties are. Right? In the periods, how the properties, and in the groups, how the properties are. That's the main thing. Here they say, elements present in the same group are having similar features. That is what the point to be noted. Right? The elements present in the group, in the vertical columns group, all the elements are having similar features according to Mr. Mendeleev's periodic table. You have to remember, same features or similar properties in the groups. Right? Now, let's come back to the properties of the elements in the periods. The horizontal one, right, are nothing but the what we call periods. So those periods, the properties of the elements have been keep on changing, right? The elements present in the period, they are having different properties. So this is nothing but the classification or the Mendeleev periodic table. So I said important points about the Mendeleev periodic table. We will come across what are the limitations, what are the silent features. So these are the silent features. Now we will be discussing about what are the positive points, right, of the Mendeleev periodic table and what are the limitations and how the limitations have been rectified in the next modern periodic table. We will come along, right? Let's see in the next video, please. Thank you.